Okay, let's give you guys some more practice. So find the radius of convergence and the interval of convergence for this power series. So press pause and have a go. Okay, so to do this, we're going to need to compute this value here. So we always need to get an plus 1 divided by an. Well, this is your an plus 1 divided by an is the same as multiplying by the reciprocal of an, which will be this. So now tidy this up. So tidying this up, so hang on. So visualize this block as being one block multiplying another block, and then visualize this block here as being 10 to the power of n times 10. And then you can see that this will then cancel out with this block here, and then hang on, and then this 10 to the power of n will cancel out with this 10 to the power of n. So these two will cancel out. So that will leave you with this, which will be this thing here, and then your n will be here, and then n plus 1, and then you've got your 10. So this whole thing here will then become this. Okay, and then group all the n's together. So group all the n's together. That will then give you this, and then this is x minus 2, and then you've got your 10. You've got your 10 here. So this whole thing here will then become this, because n is always positive. So this will always be positive. This will always be positive. So when you take the absolute here, this thing here will always be positive. So you don't really need the apps here. So this whole thing here will then become this. Well, this remains the same. So from here, that will then take us to here. So with the ratio test, for convergence, we require this value here to be less than 1. If it's greater than 1, the series will diverge. If it equals 1, it's going to be inconclusive. So because we want our series to converge, we require this to be less than 1. So for convergence, we require this whole thing here to be less than 1. So if this whole thing here is less than 1, our series will converge. Well, as n heads towards infinity, this is going to head towards 1. So you trying to make this to be less than 1 is really you trying to make this to be less than 1. The minute you can make this to be less than 1, then the whole thing here will be less than 1, because the limit of this heads, well, it's going to be 1 as n heads towards infinity. So you wanting to make this to be less than 1, well, just concentrate on making this. So concentrate on making this to be less than 1. So for convergence, we require this to be less than 1, because the minute this is less than 1, then the whole thing here will be less than 1. So we will have convergence. So just concentrate on making this to be less than 1. So hang on. Remember, absolute of a over b, that's the same as abs of a divided by abs of b. So looking at this, take the abs here, and then take the abs here. Well, the point is that when you take the absolute value of positive 10, it will always be 10. So this thing here is really the number 10. Absolute value of positive 10 will be 10. So now times both sides by 10. That will then give you this. So here, looking at this, the radius of convergence is really 10 centered at 2. But let's imagine we didn't know that. So from here, translate this to this. So you can always translate the same thing to this. So now add both sides by 2. Add everything by 2. That will then give you 12. This adds 2. That will give you negative 8. So for convergence, we require x to be in between here and here. So going back to the very start, for this series to converge, we require x to be anywhere in between negative 8 and positive 12. And anywhere in between, we know it's going to converge, because we deliberately made well, anywhere in between negative 8 and positive 12, this value here will be less than 1, so it will converge. So hang on, going back to here, bear with me. So going back to here, this is where we're at. For this to converge, anything in between here this series will converge. But the thing is, if you put that on -8 and that on +12, this value here, an plus 1 over an, hang on, bear with me, as n tends to infinity, that on -8, this value here will equal precisely 1, which will be inconclusive. That on 12, this value here will be equal to 1, which will be inconclusive. So anything less, anything in between, we know this is going to converge. But that on 8, that on -8, and that on 12, it will be inconclusive. So we need to check. We need to manually check -8 and +12, which we will do in the next video. Okay.